out with everyone once it is ready to go. So hopefully it starts to record. You should see a message pop up that we are going to be recording. So thank you all for being here. And I'm going to turn it over to Jeff Green with the Minnesota Department of Natural Resources to speak with us about groundwater and karst. So take it away, Jeff.
Good afternoon, everybody. It's really nice to be with you, even if it is virtually or remotely or whatever it is. It's the way things are these days. Um, like Stephanie said, I'm going to talk about groundwater, karst, us, and what we've got going on here in Olmsted County. I've been doing this work for the Minnesota DNR since May of 1990, so in a couple of weeks, it'll be 31 years. And a couple of weeks, I actually am retiring from the DNR. So this is kind of my swan song, I guess. Um, so it's been a fun career, interesting career. And this is, I'm just going to share with you some of the things I've learned over the years and what we've seen. And Stephanie, it is on full screen, right? Where it's just showing the one slide.
Yes,
All
yep,
right,
I see your title slide full screen.
wonderful. Um, if I was doing a little different talk where we talk about the fluorescent dye tracing work we've done for the last 30 plus years, that talk's actually titled Dying in the Driftless, which is a lovely title. I tried to figure out how to make it work for this talk, but it's just going to be too much of a stretch. But we are going to talk about fluorescent dye tracing, karst, sinkholes, buildings that are been compromised by sinkholes, and just a number of other things. Well, about 500 million years ago, Minnesota was on the actually a little south of the equator. That line is that's the equator right there, and this is north. And here's where Minnesota was, and you can see most of Minnesota was dry. That was the Precambrian rock that was deposited somewhere between 1 or so billion years ago and 3.5 billion years ago. And notice southeast Minnesota was ocean. It had seas coming in and out. And those seas left behind rocks. And those rocks are what make aquifers. And an aquifer is not, there's no special definition of what an aquifer is, no numeric definition. An aquifer is just a layer of sediment or bedrock that can yield economical quantities of water to wells or springs. And that economical quantities is going to depend on where you are. When my wife and I lived in northwest Nebraska, where they had the pure shale formation, if you got 5 gallons a minute out of a well, you were thrilled. Here, that would be considered an aquitard or a low permeability layer. So aquifers, which is what we're going to look at water moving through here, it's really just a what works for you. We find water in the ground. It's in sands. This is the blue. That's water. It's in between sand grains or in the fractures of rock, fractures in granite. That's up in northern Minnesota, or caverns or big conduits in limestone, which is what we have down here in southeast Minnesota. And that water moves. It moves through the ground, falls from the skies, precipitation. Some of it infiltrates. It moves through. And then it comes to lakes or rivers or streams or oceans and it evaporates. And that's what drives our groundwater system here in Olmsted County and throughout the world. 270 million to 520 million years ago, like I had said earlier, this southeast part of Minnesota was covered by seas. And the seas came in, the seas left. The seas left behind sands and silts and clays that make up the bed, that lithified and make up the bedrock we have. And in fact, that sandstone, that's what drove our frac sand mining boom here a number of years ago, which that boom has now gone bust. So that this area, this Hollandale embayment, as we call it in geology, provides us with karst. It provides us with lots of aquifers. We really kind of are, especially as you get down here. This is Mower County down here into Fillmore County. It's kind of the Saudi Arabia of aquifers. We are very, very blessed with abundant groundwater resources here. Now you go over here into where the Precambrian granites and quartzites and things are. Southwestern Minnesota, they are water poor. In fact, this corner of southwest Minnesota, Worthington is probably the largest city in it. That's actually in the Missouri River Basin, and they're getting water from the Missouri River now. They don't have enough water there, enough groundwater. In the last couple million years, this landscape of sedimentary rock had glaciers come down. Southwest Wisconsin is truly driftless. It never had glaciers on it, at least not in the last several million years. Southeast Minnesota, where we are, we were glaciated, but it was sometime in the pre-Illinoian, 500,000 years to a couple million years ago, we did have glaciers here. And you can find things that will tell you, you find rocks. In fact, the biggest agate I ever found was in Fillmore County next to a limestone quarry. So we do have glacial deposits here, but we are still considered this driftless area. And this is topography of the driftless area. You can see how this rugged topography is different from all that around it, which has all been glaciated in the last couple 100,000 to 20,000 years ago. And I'm assuming many of you have heard that term, the driftless area. It actually comes from way back in the day when the prevailing thought in geology was that the Earth was 6,000 or 7,000 years old. And there had been a worldwide flood in the time of Noah, and the geologists were finding rocks that clearly didn't belong in the area where they were in Europe, and so they assumed that there were icebergs after Noah's flood, and those icebergs drifted in and brought these big rocks with them, and the icebergs melted, and we had drift. And that's why this is called the driftless area, even though that term drift doesn't really describe the icebergs of Noah's flood anymore. It just means rocks that have been moved. And what we got left behind here is this stratigraphic column that goes all the way down to the billion-plus-year-old igneous and metamorphic rocks, and then comes up through fine-grained material, coarser-grained material, and then carbonate. That's the green material. And the carbonate is stuff that will dissolve under acidic groundwater moving through it. This is what the glaciers left behind, or the seas left behind in a map view. And all these pastel colors are carbonate rock, limestone, dolomite, rocks that are pretty readily soluble. And that's what gives us karst. I'm hoping most of you have heard the term karst. It actually comes from what used to be Yugoslavia. The word was kras. It meant a dry, waterless place. All the water goes into the ground through disappearing streams, sinkholes, or what are actually called dolines in Europe, thin soils over bedrock. A bunch of years ago, and some of you who are my vintage or a little younger may remember this, a U.S. pilot named Scott O'Grady got shot down during the peacekeeping missions when the war in the Baltics was going on between Serbia and Croatia and Bosnia-Herzegovina. And his survival training served him in good stead, except he couldn't find any water. And that's because he was in the generic kras. He was in this dry, waterless place. That word got Germanized as karst. And Jovan Cvijic, if I'm not even sure I pronounced his name right, he is the father of karst geomorphology. He published the first scholarly study of karst. in 1893. And the field has taken off from there. It's more recognized in Europe. There are major European universities with karst institutes. Karst is more of a stepchild of geology here, although that is slowly changing. And what happens and what makes karst is water goes into the soil. Soil has air, and that air has carbon dioxide, and water and CO2 combine to form a weak acid called carbonic acid. And that water goes into the rock, goes into existing joints in the rock that came as the rock settled, as a sediment settled and lithified. You get cracking, and that water goes in and it starts to enlarge the joints, and you get this system of interconnected joints in the bedrock, all driven by solution, which leaves behind calcite, makes our caves, makes beautiful underground caverns, things like that. But that's the dissolving of the rock makes karst, and that's what differentiates it from other types of geologic or geomorphic landscapes and aquifer systems. And karst can be very beautiful. This is the Tower of Karst in Guilin, China, which I've never been to, but really would like to get to. It's just lovely. And karst areas also tend to have a much higher concentration of endemic species, species that are at risk, unique species, and that's no different here in Minnesota. We have plant communities in the karst that are only found here in a small area of state of New York. Just across the border in Iowa, there's Ice Age snails, the Iowa Pleistocene snails that live in the karst landscape, and were thought to have gone extinct, and they've discovered they're living there. Actually, I know some people, one of their quests in life is to find Iowa Pleistocene snails here in Minnesota. So karst is really it's fascinating, unique, and very different than most of the rest of the landscape. And the original definition was that it was a type of landscape, a terrain with relief, drainage, and the rocks are soluble. And in 2000, this definition about the karst system came out. And I've been doing karst for 30 years, and I still have to think about this definition when I read it. So myself and a professor at the University of Minnesota in 2014 came out with our applied definition. Karst is a landscape scale hydrologic system formed in soluble rock, and the water dissolves the rock in largest passages, and you get a system of integrated, connected conduits, and groundwater can travel very rapidly through that at speeds of up to several miles a day. And that's really important, that rapid flow. In the rest of Minnesota, if you get groundwater moving 20 or 30 or 40 feet per day in a sand, it's really moving. Down here, the first dye trace I ever did, the water and dye went 8 1/3 miles went 2 1/3 miles in 8.5 hours, which is quite rapid groundwater flow. That dissolution we're talking about, here's an example of it. The rock is dissolved and that material is carried away, and you get openings underground. And these openings connect and integrate and form karst. And as you can imagine, water can move pretty fast through things like this. This is from Niagara County. This is a camera case. And here is that system of interconnected joints on a micro scale. This rock actually is sitting outside of the geology building at the University of Minnesota in their rock garden. It's such a beautiful example of integrated conduits. That water can move really fast. This thing is called the spigot. It's in, I believe, Spring Valley Caverns out in Fillmore County. You can see it's basically a pipe in the rock, and that is that turbulent conduit flow. In our applied karst definition, you get water moving very, very quickly. Karst develops worldwide in limestone, dolostone, gypsum, sandstone, salt. Gypsum karst can be quite spectacular. In Minnesota, our karst is in limestone, dolostone, and certain sandstones, some down here and some up in northeast Minnesota. These pastel colors, as I said earlier, they are the carbonate rock that are readily soluble with that weak solution of carbonic acid. Now, when you take this map and you overlay glacial deposits on it, what you find is southeast Minnesota is the karst hotbed of the state. Up into the Twin Cities, over along the Minnesota River at Mankato, in the area around and down the Cedar River from Austin. The rest of this has carbonate rock as first bedrock in many places. The difference is once you get above 50 feet of sediment cover, you start losing indications of karst at the surface. And not only that, the groundwater is less impacted by human activities when you've got more than 50 feet of sediment cover. I've talked to well drillers. They'll tell you drilling wells like in Dodge County, they'll be going along and all of a sudden they'll hit a void in the bedrock and their drill bit will drop 20, 30, 40, 50 feet. So this whole area is karsted bedrock, but it's not active, visible on the surface karst. This is the active, visible karst on the surface. This is a map. It's available on our website. We made this map a couple of years ago showing the active karst areas in Minnesota, or surface karst features. And karst has some pretty distinct features. It's got sinkholes, stream sinks, places where water disappears, and we're going to look at examples of all these. We have dry valleys, we have springs. You get into the European karst, and you have big, multiple square mile closed depressions with water flowing into them and not coming out. Here in Minnesota and other places, we have blind valleys, which are valleys that end at a head wall. They're considered to be blind. We've got karst features in the subsurface, conduits, joints, caves, and this highlighted, this bolded is really important. There are many areas of Minnesota's karst where there are no surface features, but lots of subsurface features. That's something I have dealt with my entire career, where people will say, well, I'm going to put a, fill in the blank of whatever development they want to put into a place, and they'll say it's not karst because there aren't any sinkholes. But you go into the subsurface and you find karst. We're actually in the process of finalizing a map of Houston County and Winona County, where we are mapping the karst landscape units without, well, we show the sinkholes, but they are indicative of karst, but not the sole story. And that's to try to get away, to try to emphasize that it can be karst and have no sinkholes, because what's happening is all in the subsurface. And this is Olmsted County, and these red triangles are sinkholes. The blue circles and the blue circle with dots are our springs. See here, this is Rochester. You see these kind of funky looking yellow symbols. We will talk about those towards the end of the talk, what's going on here in the city of Rochester. You can see pretty dense accumulations of sinkholes. This is actually called the Orion Township Sinkhole Plain. And in fact, I'm going to be down in this area just south of the river in a few hours doing dye tracing this afternoon. The karst here in Olmsted County has been mapped before. This was back in 1988. Calvin Alexander, University of Minnesota professor, now an emeritus professor, and one of his graduate students mapped the karst features of Olmsted County. We are going to be updating this map in the next few years, because Olmsted County is getting its atlas, County Geologic Atlas, revised. Well, Karst has a lot of features. Like I said, sinkholes, blind valleys, and the like. The most spectacular are caves. And Minnesota is blessed with many caves. This is Niagara Cave, down just southwest of Harmony, Minnesota. It's called Niagara Cave because it has an underground waterfall that's about somewhere between 60 and 80 feet high. It's a pretty spectacular cave. It's a show cave run by the Bishop family. Well worth going to see if you haven't been there. Our other show cave is Mystery Cave, which is part of Forestville Mystery Cave State Park. If you haven't been there, that's also well worth going to see. Niagara has more steps going up and down. Mystery, their main route, is handicapped accessible. They do have a second route where you go on a different entrance and carry your own light. But well, both of them are well worth going to see. This is the cave entrance in Rochester, just on the north side of town. It was uncovered back in 2004. The local people up there, the folks who had lived for a long time up in northwest Rochester, they knew about the cave. When I went into the cave, you could see lots of graffiti scrawled into the sandstone walls. This cave actually was in the St. Peter sandstone, which is the sandstone you see up by the Chateau Theater and at various places around town. On 2nd Street going out by the Rochester Golf and Country Club, they were just putting a development in there, and they dug back into the hillside in the St. Peter sandstone. This is a nice cave. It's now got a gate over the entrance. It's protected. It had Indian or Paleo-Indian rock carvings. Archaeologist from the Upper Mississippi Valley Archaeology Center in La Crosse came over and identified this and this as being Paleo-Indian cave drawings or cave art. It was hard to see. There was a lot of other more recent names, particularly carved into the soft sandstone, but there was a Paleo-Indian art. This is another photo, or excuse me, a photo of another cave in Olmsted County. This one is south and east of Rochester. It's actually about 10 minutes from where I live. You can see the entrance here. It's not very large. And this is a narrow crevice cave. Martin Larson, who took this photo, has become a very dedicated caver. He works for the Olmsted County Soil and Water Conservation District. And he was telling me about being in this cave, and he and another caver were trying to push it, see how far they could get. They ended up, excuse me, ended up turning back. The water got up to the ceiling as they were going through it. They had their noses up against the cave roof, and that's how they were getting their air. The water was, just a few inches from the top of the cave, and they were going through there. And I love caves. I love caving, and I don't think I could do that. They weren't fazed by it, which is signs that they're very dedicated cavers. Sinkholes, as I've talked about, they are viewed as the diagnostic feature of karst. They are quite common in southeast Minnesota. Fillmore County alone has over 10,000. The classic version of a sinkhole is this funnel-shaped depression in the landscape, usually with a hole open in the bottom. They can get quite big and quite deep. This is up in the Twin Cities in Mahtomedi. This is the top of a tree. This is a city park, fortunately. This is the top of a tree that was somewhere between 40 and 50 feet tall. The sinkhole opened abruptly one day, and the tree went in. I don't know how many of you, wait, we'll go back. I don't know how many of you remember several years ago, a sinkhole opened up in Florida, and swallowed part of a house, and a poor fellow was killed. His bedroom was in the part of the house that collapsed down into the sinkhole, and he got swallowed up. I got multiple interview requests from the media after that, as did virtually every other karst scientist I know in the U.S., because people were pretty concerned because they know, like here, they know we have sinkholes, and they were worried that this might happen in their town next. We have had a few buildings damaged by sinkholes, and I'll show you some photos of one of them here. It's not been a common thing. What is fairly common is in the spring when farmers are tilling their field, or in the fall when they are harvesting, they will discover sinkholes in their farm fields. And I've heard multiple stories from farmers who were driving along in the spring, and they were planting, and they heard a clunking noise, and they looked, and the planter had just dropped into a sinkhole that had just opened up behind their tractor. So those things do happen here. As far as I know, no one's ever been injured by one. The way they form is when you've got that network of conduits, those solution large channels, and soil moves in, and then that cover, the sediment and soil over the conduit, collapses. We have very few of our sinkholes are formed when the bedrock itself actually collapses. That's much less common. The way the mechanism works, you've got this solutionally enlarged vertical master joints. You've got the bedding planes that are connected. You got water moving through. And as water moves through the soil, it'll start carrying some of that soil away. And this is the example over here. As more water comes through, more soil comes into this void and into this conduit. And then it starts moving through, and that soil is flushed out. You get this air-filled void, it stopes upwards, and eventually the cover collapses. If it collapses slowly, you get a shallow, wide sinkhole. If it collapses quickly, you get more of a deep funnel-shaped sinkhole. And by the way, if you've got questions along the way, make sure you do send a chat question. I'll be happy to answer things as we go. So that's how sinkholes form, that water and sediment moving into the channels in the bedrock and making air-filled voids. And that's why they'll open suddenly. That soil can't support itself anymore. It just drops dramatically. Some of them are quite small. This is a small sinkhole just southeast of Rochester, not far from the city of Iota. We're in the process of pouring water into it to do a fluorescent dye trace. Sometimes they're very shallow. This is down by Leroy, Minnesota. It's a sinkhole. It's only about a foot deep, but it's actually a sinkhole. It's a closed depression over carbonate bedrock. This is Pine Island. A number of years ago, a family in the western part of Pine Island, it was evening, like around 10 o'clock, and they let their dog out to go outside to do its business and then come back in before they all went to bed. The dog wouldn't go out the door, the owner told me, and they couldn't figure out why the dog wouldn't go out in the backyard. And the next morning when they woke up, they were the proud owners of a sinkhole. Something that they had to figure out. We gave them technical advice as to how to fill it, but that was, at their expense. It opened up. You're living in Karst, and sinkholes open up, and happen to be in their backyard. We get areas of sinkholes in Olmsted County and Fillmore and others where you actually have sinkhole plains. All these clusters of trees are sinkholes. This is south of Marion on Highway 52, just south of Highway 52. This is looking south with the highway at your back. We have stream sinks, places where water goes into the ground, goes from surface water to groundwater, which is characteristic of karst. There's this real blending of what surface water is and what groundwater is. That there's that intimate connection between the land surface and the groundwater. Another example of a stream sink. And we have places here in southeast Minnesota where if it rains today, the rainwater will run off farm field or sidewalk or street, whatever. It'll run off and it's surface water. It'll disappear into a sinkhole and become groundwater. It'll be groundwater for a day or two. Then it will come out of a spring and it will be surface water. And then it will flow along again and become groundwater. And it's just, excuse me. It becomes groundwater, and we kind of lose track of it at that point. But there's that real blurring between groundwater and surface water. And that water moves through that groundwater system and it comes out as springs. And springs are the discharge point for the Karst groundwater system. This is a lovely spring in Olmsted County, southeast of Rochester. Here's another one. This is Martin Larson, who I mentioned earlier. Water coming out of the ground. Sometimes the springs are much smaller, like this one. And people have used the springs. This is Bear Spring, just southeast of Rochester. It rises behind the building now also, but if you go into this old limestone building, there's spring water coming out inside of it, and it was built to cover the spring. The springs were used by the pioneers basically as refrigeration systems. They could put milk in there and other perishables, and groundwater is 48 degrees. So you had this building that's 48, would be 48 degrees and would keep things cold. One of the characteristics of karst as the water moves to these springs is that high velocity groundwater flow. And here's the spigot again. And we map that, study that using fluorescent dyes. This is rhodamine WT. We use 3 different dyes, actually 4 different dyes, and they're all quite safe. Some of them are used in medicine, cosmetics. Like working for the DNR, it would look really bad if I put something into the groundwater that was toxic. We pour that dye in, and if the sinkhole doesn't have water flowing into it, then we flush water from a tanker truck in there to push that dye in groundwater and push that dye and water into the system. As I mentioned earlier, it can move pretty fast. This is a dye trace we did south of Rochester in a sinkhole area. We put dye into this blind valley, and it came out of this farmer's spring, and I actually got to know the farmer. It turned out he and I went to the same church, which helped because when we did the dye trace, the red dye here is what we poured into the blind valley, the stream sink in the blind valley. This is date. And basically, overnight, our red dye came through, and this is about 100 parts per billion of dye. Well, our red dye that we use is visible at about 80 parts per billion. So the spring turned red, and the farmer's horses would not drink the spring water, which upset his wife and granddaughter quite a lot. I didn't know, I couldn't imagine that they could taste it, but I'm assuming it was because it was red. I guess I didn't realize that maybe horses can see color. But the farmer asked me to never do that again to his spring, because it was not, we were not happy family members there. Karst has a lot of environmental issues. Well, and that I just mentioned that's one issue, that rapid flow, direct connections between the land surface and the groundwater, and then groundwater moving quickly through it. That is an environmental issue. This is Belchester, Minnesota, which back in 1992, their city wastewater pond collapsed. It was one of those systems where you just have a series of lagoons, and the wastewater is treated by sunlight exposure to the atmosphere, bacteria in the wastewater ponds. And the mayor of this, excuse me, the mayor of this little town of Belchester went out to do his weekly sewage lagoon inspection and discovered that their sewage lagoon had lost its 2.5 million gallons of wastewater. And a year earlier, Lewiston, Minnesota had the same thing happen. And 14, 15 years before that, it happened to Altura, Minnesota. So it was a big deal. We never did know where the wastewater went to. We offered to dye trace and were told that they were concerned about our toxic dye, which dye is not toxic, but there was a lot of interest in not figuring out where that wastewater went. The groundwater, the springs, as I said, they are affected by the surface, by surface runoff. This is the Fountain Big Spring, which is right along the road, the county road northwest of Fountain. You can drive to it. You can go up into it. It's a cave. This is how it looks during low flow. And this is how it looks when you get lots of runoff. The water quality can change dramatically, and sediment will come pouring out in the spring water. This is not unusual. This happens in many springs in southeast Minnesota, including a number in Olmsted County. Over in Dodge County, they looked at wells and nitrates. The blue are nitrate values, and this is a karst area. It's less than 50 feet of cover over karsted bedrock. You can see our nitrate numbers: 11. The drinking water standard is 10, 11, 14, 22.1, which I'm not convinced that is the right aquifer. 3, 4. Lots of groundwater impacts in karst areas. Whoops. This is an older example. This is from the 1940s. A doctor in Rochester had built a house, and the house is kind of directly across from the Plummer house. It's on the hill across from the Plummer house. Doctor built his house. People were getting gastrointestinal illness, and they discovered that his septic system with its leaching pit had been blown into the bedrock. They basically excavated the rock and dumped the sewage, the septic effluent, into this leaching pit, and it would go, they poured dye in here, and within an hour or two, it was in the good doctor's well. So they ended up drilling a new well, and I believe they modified the septic system also, but it was a case right here in Rochester of contaminated groundwater making people sick. This is the little town of Harmony, Minnesota. They had the same thing happen down there, but on a bigger scale, with people getting typhoid fever. Another environmental issue with karst are sinkholes being used as dumps. This is in Olmsted County. Most of the sinkholes that I go into that have junk, have old junk. There's been a lot of folks trying to educate the public that sinkholes aren't good places to be dumps, and that has been very effective. It was on the wane when I got here in 1990, and it has decreased even more. But there are still a few examples, and this is one. a TV. That's a pretty good example, or a pretty good indicator that this has been happening in the not too distant past. But like I said, it's getting less common. And I want to kind of wrap up with talking about things here in Rochester. This is the sandstone, St. Peter sandstone exposure at the Chateau Theater in Northeast Rochester. You can see the rock here, and you see this, which looks different. It's actually an ancient sinkhole that is filled with unconsolidated sand. It's a very large feature. It was found across the road, across Circle Drive from the chateau. If you stand at this and you look south, you can see another hill. It was also found there. These things are massive. This is actually a regular stop when we do field tours down here. When you work in geology and groundwater and karst, one of the things you get to do is go on actual field trips where you go out and look at things out in the landscape. And we've been here many times. The Chateau Theater graciously allows us to come on, and we look at this feature, and it's, like I said, it's quite large, and it is not uncommon. This is Rochester. These are the, I'm sorry, those are awfully small. I should have zoomed in more. These are yellow. These yellow things are voids. We have had multiple examples of these St. Peter sandstone, Shakopee, dolostone, buried subterranean features affect building in Rochester. Several years ago, it was in the newspaper as they were reconstructing the Miracle Mile shopping center and putting in the Fresh Time grocery store with apartments above it. They hit a large void in the bedrock, and it cost about $1.2 million to fix it. So it was a tax incremental financing project, and that's where the money came from. It had been rumored and whispered about, and then it turned out it was true. When St. Mary's Hospital had the parking structure built, that also encountered one of these, one of the mail buildings downtown. It had the same problem in both those cases. Well, on the Miracle Mile, they could stabilize it. But one case where they couldn't was a hotel on South Broadway, a hotel whose names have changed, whose name has changed multiple times in my time here. Here is 16th Street, here's Broadway, the fairgrounds. It's this hotel. And I've been in this hotel, and when I was in it, I thought it was kind of funny shaped. You know, why is it like this odd kind of angled thing? It's, well, because they were supposed to put a wing going straight south, and they discovered one of these voids, and to engineer it, to stabilize it, was so expensive that it was cheaper to just not build the wing of the hotel. And the consulting firm that gave this recommendation said the owners of the hotel, the developers, were very, very unhappy. But that's why that hotel looks that way. It was supposed to have this third wing. Back in 1971, a house in far south Rochester had sinkholes open up next to it. And there's actually another one opened up right next to the foundation. The city ended up buying out the people and moving them and bulldozing the house down. It's where Fleet Farm used to be. There's a frontage road, and it swings up, and it was the lowest house along that frontage road going up the hill, and they moved it. I've thrown a lot of stuff at you. If you're interested in this, the Minnesota Conservation Volunteer Magazine, which is our DNR magazine, has had a couple stories about karst and groundwater. One was May, June 2020 about the farmer who went underground, and the dye tracing work that I do was featured in March, April of 2016. And then we have a statewide spring inventory online. We have a groundwater tracing database online, a karst features database that we're working on getting online. And this can all be accessed through our DNR Karst and Springs webpage. I'm going to brag a little bit. We have some of the best online information in the US and actually in the world. We are, myself and particularly some colleagues who are much more astute with these things, have labored hard to get this information online, and we are, we have a lot of people are quite envious of what we've been able to do here. And it's all thanks to the taxpayers who have supported the Environmental Trust Fund and the Clean Water Land and Legacy Amendment. And we're putting that money to good use. And I'll take any questions if anybody has a question.
Thank you, Jeff. This was a wonderful presentation, and I learned quite a lot and was a refresher for many other karst tidbits. One of the questions that did come into the chat was, what are the permitted levels of nitrates in wells?
Oh, that's a good question. It's a complicated answer. The drinking water standard is 10. Above 10 parts per million, you start getting health impacts, particularly with infants, where the nitrate replaces oxygen on the hemoglobin, and infants will turn blue, and that includes like pigs and basically mammals. I believe when a new well is drilled, and that's handled through the Minnesota Department of Health, or well, in Olmsted County, it's handled through Olmsted County. They're delegated to do that. I believe if it's above 3, you are not allowed to use it, but I'm not positive. Now, if you have a well that is over 10, there are no regulations that make you replace it. That's up to you, but it does affect new well construction.
Yeah, and we do have an upcoming nitrate screening clinic for drinking water for private wells in Rochester. Well, it's happening in Rochester at 125 Live, so the details are in the chat. You can also find them on our We Are Water website. So one of the questions that just came in is, what factors lead people to hypothesize where sinkholes are?
Well, what you do is you look at, well, first you have to have bedrock that's soluble, and it's either limestone or dolostone or some of the sandstones here. You need less than 50 feet of material over it. That's kind of been our magic number, is 50 feet. So it's got to be less than 50 feet. And then the best predictor is, are there other sinkholes on the surface? They tend to occur together, though you can certainly get isolated sinkholes. But yeah, it's that depth of cover over the soluble bedrock, and then some with topography. If you were on a really steep slope, the kind you would get winded walking up, you very rarely, or I've very rarely found sinkholes on those. I have found cave entrances on those. We call them solution pits, but usually it's that lack of steep slopes, less than 50 feet over soluble rock. That's where you will look for sinkholes, and that's what our mapping, our potential karst surface feature development map shows, although we didn't factor in the steep slopes, but the less than 50 feet over soluble rock.
Okay, I see that Ray has a hand raised. Do you have a question?
Yeah, I'm too lazy to type it.
That's fine. Go ahead.
The Minnesota Geological Survey has created the idea that there is this boundary layer. Now, the survey was, what, 70 years ago? That separates the upper layers from the areas that we actually draw drinking water from. How much more study has been done of the permeability of that boundary layer? Is the karst geography creating a situation where, in fact, that boundary layer is not as impermeable as it was when the survey was done?
Okay, I believe you're talking about the Decorah Shale.
The boundary layer that separates the lower from upper layers.
Yeah, that's the Decorah Shale. That's what's below the karsted, the upper karst area around here. If you're in Rochester, when you go, well, if you go on Highway 52 out of town, you're driving over the Prairie du Chien karst system, which has got the St. Peter sandstone in it too. That's what the big voids are. And then you go up on top, and on top you're in the Galena limestone, and below that is the Decorah Shale. On the uplands, we have not seen much water movement through that shale. And that shale actually, when the upper limestone, the Galena limestone groundwater goes over that edge, actually at the Decorah Shale, and its associated biotic communities filter the groundwater, filter out the nitrates. But when you get out into that upland plateau, the Decorah Shale has done a pretty good job of keeping anthropogenic impacts, chemicals from moving through it. So like Rochester, we've got multiple city wells up on top of the plateau, and they are still producing high quality drinking water. So it's still relatively intact. When you get to the valley edges, then it gets fractured, which is that's every bedrock unit we've got. It gets fractured when you get to its valley edges. So it's doing a good job. And here, as we go east, however, like into Winona County, it's absent, and you're in that St. Peter sandstone, Prairie du Chien, dolomite, bedrock, and that is heavily impacted. It's actually in Olmsted County back in the 60s, and then statewide in the 70s. There were laws developed that say you cannot drill a drinking water supply well in any areas that have less than 50 feet of cover over karsted, or over limestone, over carbonate rock, to protect public health. So hopefully I answered your question.
Okay, we have one more question come in. In what instances does the city or county assume financial responsibility for repair or mitigation for sinkholes on private property? Jeff, I'm not sure if you're able to answer that, but you can certainly take a go at it if you'd like.
I am only aware of the one, which was the house I showed, the Grohl residence on the south side of Rochester. That is the only one a private residence I am aware of. That, well, one, that's been damaged by a sinkhole, and two, that the city went in and bought them out. The Miracle Mile, that was a tax incremental financing project, and so the developer came back to the city and ended up getting 1.2 million more. So, when there's development going on, and it's taxpayer funded to some extent, that's very different. But in terms of private residences, I'm only aware of the one. There haven't been, there was like the people in Pine Island. There was another case down in Ostrander, Minnesota, where a sinkhole opened up in somebody's backyard. I've seen multiple sinkholes in backyards, but like I said, the only time that, as far as I know, a governmental agency went in and bought somebody out was that one back in 1971. We will go and provide technical help. I have been in many a yard trying to help a landowner figure out, is it indeed a real sinkhole? And if it is, what can they do? And we do that as part of our public service to the citizens of our state. So we do give technical help, but like I said, that one instance is the only one I know.
All right. Well, thank you for sharing your time and knowledge with us, Jeff, and thank you for everyone who was able to join us. It is just a few minutes past 1, so if you need to head out, thank you again so much for being here, and we'll be sharing the recording of this as long as everything cooperates, and enjoy. We hope to see you at another We Are Water event or EarthFest event. So thank you, everyone.
Yes, thank you for listening.